Good morning, students. Am I audible, visible? Vishnu, Chinmay? Am I audible? Can you hear me? Nasreen? Vishnu? Okay. So today we'll start a new topic. So today we'll start a new topic of differential equation, which is very, very important from JEE point of view. Most of the times, JEE is asking question on differential equation, that is linear differential equation, right? So write down linear differential equation. Linear differential equation. Write down the differential equation in which the dependent variable and its derivative the differential equation in which the dependent variable and its derivative appear in first degree is called a linear differential equation. Is called a linear differential equation. Okay, if y is a function of x, then y is called a dependent variable, x is called independent variable. Suppose y is a function of x. Okay, y is called dependent variable, x is called independent variable. If in a differential equation, all the powers of y is 1 and power of dy upon dx is 1, then we can say that the differential equation is a linear differential equation. Is it clear, Vishnu? Is it clear? So differential equation, linear differential equation means the dependent variable, power of the dependent variable and its derivative should be equal to 1. Then come to the format of differential equation. Format of linear differential equation. Format of linear differential equation. So first form is dy upon dx. If y is a function of x, then dy upon dx plus py equals to q. Dy upon dx plus q py is equal to q, where p and q are functions of x, where p and q are functions of x is a linear differential equation. dy upon dx plus py is equal to q, where p and q are functions of x, is called a linear differential equation. Now the question is how to solve a linear differential equation. To solve a linear differential equation, we have to convert the left-hand side of the differential equation into a total derivative product of the dependent variable. Okay, we have to convert the left-hand side into a total derivative. The left-hand side can be converted into total derivative by multiplying a suitable factor to both sides of the equation. That factor is known as integrating factor. The suitable factor is known as integrating factor. Write down, which is very, very important. Integrating factor. Integrating factor, or IF in short form, which is equal to e power integral p dx. What is p? P is a function of x, right? If we multiply the integrating factor, that is e into e raised to the power p dx, to both sides of the equation, then the left-hand side of the equation will be converted into total derivative of product of the dependent variable and integrating factor. Okay, then you can apply variable separable form to solve the differential equation. Suppose this is equation 1. Now multiplying IF to both sides of equation 1. Write down, multiplying integrating factor, or IF, to both sides of equation 1. Multiplying IF to both sides of equation 1. So e raised to the power integral p dx into dy upon dx plus py into e raised to the power integral p dx equals q into e raised to the power integral p dx. Okay, now just remember it. When you multiply integrating factor to both sides of the linear differential equation, the left-hand side of the equation will be the total derivative of product of dependent variable and its integrating factor. So left-hand side will be to derivative of product of dependent variable, that is y, into e power integral p dx. Now check it. Differentiate this function and check whether it is equal to left-hand side of the equation or not. If we differentiate this function, this function is the product of two functions. One of the function is y, the second one is integrating factor. So applying product rule, dy upon dx into e raised to the power integral p dx plus y into derivative of e power integral p dx is equal to e raised to the power integral p dx, and the derivative of integral p dx is p. Okay, so just remember, when we multiply integrating factor to both sides of the linear differential equation, the left-hand side of the equation will be derivative of product of dependent variable and integrating factor. So d upon dx of y into e power integral p dx equals q into e power integral p dx. If the derivative of left-hand side is equal to right-hand side, then integration of the right-hand side will be equal to left-hand side. Then we can write y into e power integral p dx equals integral q into e power integral p dx whole dx. Okay. Then what is y? Y is equal to, I'm writing it separately, y equals to integral q into e power integral p dx whole dx upon e power integral p dx. Okay, this is the y. You should remember the procedure. You should not remember the last result. Okay, the procedure is, first of all, bring the equation into the form dy upon dx plus py is equal to q. That means the coefficient of the dy upon dx should be equal to 1. Then find the integrating factor. Integrating factor is equal to e power integral p dx. Then multiply the integrating factor to both sides of the equation. After multiplication, the left-hand side will be the total derivative of product of dependent variable and integrating factor. Then integrate the right-hand side, then you'll get the unknown function. This is the total procedure. So I hope it is clear to you. Let me know in the chat box, is it clear to you? So guys, let me know whether the last part which I have written in the top of the board is visible to you. Vishnu, the last part, is it visible? Okay. If the y is a function of x, then format of the equation is dy upon dx plus py is equal to q. If x is a function of y, if x is a function of y, if x is a function of y, then the format of the equation dx upon dy plus px is equal to q. Dx upon dy plus px is equal to q, where p and q are functions of y, where p and q are functions of y, where p and q are functions of y. Here the integrating factor is e raised to the power integral p dy. This is the second format. Okay, integrating factor is equal to e power integral p dy. So now multiply integrating factor to both sides of the equation 1, multiplying integrating factor to both sides of equation 1, which will be e raised to the power integral p dy into dy upon dx plus px into e power integral p dy is equal to q into e power integral p dy. Okay, when you multiply integrating factor to both sides of the equation, then the left-hand side of the equation will be derivative of product of dependent variable. Since x is a function of y, here the dependent variable is x into e power integral p dy equals q into e power integral p dy. This implies x into e power integral p dy is equal to integral q into e power integral p dy. This implies x is equal to integral q into e power integral p dy upon e power integral p dy. Okay, try to remember the procedure, not the result. Did you understand, guys? Please write in the chat box. Is it clear to you? Okay. So let us come to solve a couple of questions. Question number 1. solve 1 plus x square into dy upon dx plus 2xy equals to x square. 1 plus x square into dy upon dx plus 2xy is equal to 1 is equal to x square. Now the equation is not in the form of dy upon dx plus py is equal to q. In the form of dy upon dx plus py is equal to q, the coefficient of dy upon dx should be equal to 1. Here the coefficient is 1 plus x square. So to bring into the form of the differential equation, linear differential equation, now divide both sides of the equation up by 1 plus x square. So dividing both sides by 1 plus x square, what we will get? What dy upon dx plus 2xy, 2x upon 1 plus x square into y equals x square upon 1 plus x square. Now the equation is in the form of dy upon dx plus py is equal to q. What is p here? P is equal to 2x upon 1 plus x square. Q is equal to x square upon 1 plus x square. Let the equation be equation 1. Now we have to find the integrating factor. Integrating factor IF is equal to e power integral p dx e raised to the power integral 2x upon 1 plus x square dx. You know, derivative of 1 plus x square is 2x. If you substitute 1 plus x square is equal to t, then 2x dx will be dt. Integral dt by t is ln t. So directly we can write the result e raised to the power ln 1 plus x square. E raised to the, all of you know that e raised to the power ln x, e raised to the power ln x is x. So e raised to the power ln 1 plus x square is equal to 1 plus x square. Okay. So 1 plus x square is the integrating factor. Now multiplying integrating factor to both sides of equation 1, multiplying IF to both sides of equation 1, the equation will be 1 plus x square. Again, the equation takes the first form, 1 plus x square dy upon dx plus 2xy equals x square. So after multiplication, the left-hand side of the equation will be derivative of product of the dependent variable. Here the dependent variable is y into integrating factor, that is 1 plus x square equals x square. This implies y whole into 1 plus x square is equal to integral x square dx. This is equal to x cube upon 3 plus c. So y into 1 plus x square equals x cube upon 3 plus c. This is the solution of the differential equation, given differential equation. Hope it is clear to you. Please write in the chat box. Power kote ekla tumte bond ekla. Okay, next come to the next question. Question number 2. So JEE Main 2025, 7th April shift 2. If y is equal to y of x, if y is equal to y of x, be the solution of the differential equation if y is equal to y of x, with the solution of the differential equation x square plus 1 into dy upon dx plus 2 minus 2xy equals x to the power 4 plus 2x square plus 1 into cosine x, and y of 0 is equal to 0 and y of x. Okay, this is the question. So first check whether the equation is in the form of dy upon dx plus py is equal to q. Here the equation is not in the form of dy upon dx plus py is equal to q. So in the form of linear differential equation, the coefficient of dy upon dx should be equal to 1. Here the coefficient is x square plus 1. Now divide both sides of the equation by x square plus 1. So dividing both sides by x square plus 1, the equation will be dy upon dx minus 2x upon x square plus 1 into y. The right hand side is x square plus 1 whole square into cos x. X square plus 1 whole square into cos x upon x square plus 1. So x square plus 1 cancels, right? So now the integrating factor, this is equation 1. Integrating factor IF is equal to e power integral pdx minus 2x upon x square plus 1 dx. You know, derivative of x square plus 1 is 2x. So e to the power, this one will be e power minus ln 1 plus x square. This is equal to e raised to the power ln 1 plus x square raised to the power minus 1 is equal to 1 upon 1 plus x square. This is the integrating factor. Now multiplying integrating factor to both sides, multiplying IF to both sides of the equation, multiplying IF to both sides of the equation, the left hand side of the equation will be 1 upon x square, 1 upon 1 plus x square into dy upon dx minus 2xy upon 1 plus x square whole square is equal to x square plus 1 into cos x upon x square plus 1. So x square plus 1, x square plus 1 cancels. After multiplication, the left-hand side of the equation will be derivative of dependent variable, that is y, and integrating factor 1 plus x square is equal to cos x. This implies y upon 1 plus x square is equal to integral cos x dx. This is equal to sin x plus c. Initial value is given, boundary value y0 is equal to 0. That means when x is equal to 0, then y is equal to 0. Taking x is equal to 0 and y is equal to 0. Taking x is equal to 0 and y is equal to 0. Now substitute x is equal to 0 and y is equal to 0 in the solution obtained. You will get 0 upon 1 plus 0 is equal to sin 0 is 0 plus c, implies c is equal to 0. So the required solution is y upon 1 plus x square equals to sin x. This implies y equals 1 plus x square into sin x. This is the required solution. Did you understand, guys? Is it clear to you? Write in the chat box. Is it clear? Chinmay, Vishnu. Okay. Quickly note it down. Then we'll go for next question. Last वाला part नहीं समझाया. कौन सा part बेटा? From this part, this one. Tell me from this step or from this step or from this step, which one? Nasrin, should I explain it again from this step? Okay. So the integrating factor is here. The integrating factor is 1 upon 1 plus x square. The equation is dy upon dx. So let me solve it again. Okay. Let me solve it again. It will be better. It is given that y is a function of x with the solution of the differential equation x square plus 1 into dy upon dx minus 2xy equals x to the power 4 plus 2x square plus 1 into cos x. This is nothing, x square plus 1 whole square, sorry. X square plus 1 whole square, right? First of all, we have to divide both sides of the equation by x square plus 1. So that it will take the form of the linear differential equation. On dividing both sides by 1 plus x square, the equation will be dy upon dx minus 2x upon 1 plus x square into y equals x square plus 1 whole square into cos x upon x square plus 1. So this power cancels. Now the equation is of the form dy upon dx plus py is equal to q. So integrating factor if is equal to e raised to the power integral p dx minus 2x upon 1 plus x square dx. You know, derivative of 1 plus x square is 2x. If you substitute 1 plus x square is equal to t, then 2x dx will be dt minus 2x dx will be minus dt e raised to the power minus dt upon t e raised to the power minus ln t. So e raised to the power ln t to the power minus 1 e raised to the power ln t to the power minus 1 is equal to t to the power minus 1 because e raised to the power ln x is equal to x. So what is t? This is equal to 1 upon t. The t is equal to 1 plus x square. 1 upon 1 plus x square is the integrating factor. Now we have to multiply integrating factor to both sides of the equation 1. This is equation 1, right? If we multiply 1 upon 1 plus x square to both sides, the equation will be 1 upon 1 plus x square into dy upon dx minus 2xy upon 1 plus x square whole square, then x square plus 1 cancels cos x. Is it clear? So after multiplication, I have already told you, after multiplication, the left-hand side of the equation will be the derivative of product of the dependent variable and integrating factor. Here dependent variable is y and the integrating factor is 1 upon 1 plus x square. So left-hand side will be d upon dx of y into 1 plus x square is equal to cos x. This implies y upon 1 plus x square. If the derivative of this is equal to cos x, then integration of cos x will be this function. So y upon 1 plus x square equals to integral cos x dx. Integral cos x dx is sin x plus c. Now we have to substitute the boundary value. The boundary value or initial value. Initial value is given y0 is equal to 0. Y0 is equal to 0 means when x is equal to 0, then y is equal to 0. Now put x is equal to 0 and y is equal to 0 in the solution obtained. If we substitute y is equal to 0 and x is equal to 0, the left hand side will be 0 upon 1 plus 0 is equal to, the right hand side will be sin 0 plus c. The value of sin 0 is 0, 0 plus c. So c is equal to 0. So solution obtained is y upon 1 plus x square is equal to sin x or y is equal to 1 plus x square into sin x. Nasreen, is it clear? I hope it is clear to you. Nasreen, write in the chat box. Okay, let's move forward to the next question. Okay, next question. Question number 3. Let y is equal to y of x. Let y is equal to y of x be the solution curve of the differential equation. Be the solution curve it is also JEE main question, JEE main 2025. Solution curve of the differential equation x into x square plus e raised to the power x into dy plus e raised to the power x into x minus 2 into y minus x cube into dx is equal to 0, where x greater than 0 and passing through the point and passing through the point 1, 0, find y of 2. Find y of 2 or f of 2. Okay, if y is equal to f of x with the solution curve, then find f of 2. Okay, try to solve this question. Take 5 minutes of time and try to solve. Okay. Square. Something x into, sorry. This is x into, sorry. This is not x square. This is x into x square plus e raised to the power x into dy upon dx. E power x minus 2y minus x cubed, right? So x into, first arrange the terms and put the equation in the form dy upon dx plus py is equal to q, x into x square plus e raised to the power x into dy equals x cube minus e raised power x into x minus 2 into y whole into dx. So dy upon dx equals x cube minus e raised to the power x into x minus 2 into y upon x into x square plus e raised to the power x. So dy upon dx equals x cube upon x into x square plus e raised to the power x minus e raised to the power x into x minus 2 into y upon x into x square plus e raised to the power x. This implies dy upon dx plus e raised to the power x into x minus 2 upon x into x square plus e raised to the power x into y is equal to x cube upon x into x square plus e raised to the power x. Now the equation is of the form dy upon dx plus dy is equal to q. Okay. Now you can apply the form or find the integrating factor, then multiply it, then find the solution. Can you solve this? Kinmoy, can you solve? Nasreen, सैमसंग डिस्टर्ब कर रहा है. हुई सैमसंग. Nasreen, हुई सैमसंग. ये सर पता नहीं. मेरी फ्रेंड बन जाओ. Okay, okay. Samsung, please don't disturb. Can you handle this question or I should start solving? Okay, let me solve. The curve is passing through point 1, 0, and we have to find y up to. Okay. So dy upon dx plus e raised to the power x into x minus 2 upon. So if you take x square as common, so x cube plus 1 plus e raised to the power x upon x square into y equals x square upon x square plus e raised to the power x. So integrating factor is now divide again simplify dy upon dx plus e raised to the power x 1 upon x square minus 2 upon x cube divided by 1 plus e power x upon x square into y equals x square plus e raised to the power x. Now, integrating factor IF is equal to e raised to the power integral p dx. So e raised to the power integral e power x 1 upon x square minus 2 upon x cube upon 1 plus e power x upon x square. So can we erase this portion? So now substitute 1 plus e power x upon x square is equal to t. This implies x square into e raised to the power x minus e raised to the power x into 2x upon x to the power 4 dx will be dt. So this is equal to, if you take e raised to the power x as common, e raised to the power x minus, sorry, x square. 1 upon x square minus 2 upon x cube dx will be dt. Okay, so dt by t is ln t. So this one will be e raised to the power ln e raised to the power x into 1 upon x square minus 2 upon x cube upon, oh sorry, ln 1 plus e raised to the power x upon x square. This is equal to 1 plus e raised to the power x upon x square. This is equal to x square plus e raised to the power x upon x square. Now we have to multiply integrating factor to both sides of this is equation 1. Multiplying IF to both sides of equation 1. Multiplying IF to both sides of equation 1. The equation will be dy x square plus e raised to the power x upon e raised to the power x into dy upon dx plus e raised to the power x plus x square plus e raised to the power x upon x square into e raised to the power x into 1 by x square minus 2 by x cube divided by 1 plus e raised to the power x upon x square is equal to x square upon x square plus e raised to the power x into x square plus e raised to the power x upon x square. This cancels. After multiplication, the left hand side will be total derivative of dependent variable and integrating factor. Y into x square plus e raised to the power x upon x square is equal to 1. This implies y into x square plus e raised to the power x upon x square integral dx. Integral dx will be x plus c. The curve is passing through 1, 0. That is when x is equal to 1, then y is equal to 0. X is equal to 1, y is equal to 0. Substitute x is equal to 1, y is equal to 0. Left hand side will be 0. Right hand side will be 1 plus c. So this implies c is equal to minus 1. So equation of the curve is y into x square plus e raised to the power x upon x square is equal to x minus 1. So y up to means if we find the value of y when x is equal to 2. So put y into put x is equal to 2 in the given solution. So y into 4 plus e upon 4 plus e square upon 4 is equal to 2 minus 1 is equal to 1. So y is equal to 1 upon 4 plus e square upon 4. This is equal to 4 upon 4 plus e square. Okay. काफी lengthy question. Got it? Is it clear? Should we move for the next question? Hello. Okay. So next question is, in the second section, in the next session, I'll discuss homogeneous differential equation. Riemann 2025 if a curve y is equal to y of x passes through the point one comma pi over 2 and satisfies seven x to the power 4 into cot y minus e to the power x into cosec y into dx upon dy equals x to the power 5, where x greater equal to 1 Then at x is equal to 2, find cos y. At x is equal to 2, find cos y. Okay. Now try to solve it. What is the answer? Cos pi by 2 is equal to 0. Okay, let me check. Cos of y. Now, since it is not cos pi by 2, at x is equal to 2 cos y. Answer is not 0. Answer is 2 square plus e upon 64. Answer is 2 square plus e upon 64. Irma, what is your answer? So rewrite the equation dy upon dx equals 7x to the power 4 into cot y minus e power x into cosec y upon x to the power 5. This is 7 by x into cos y by sin y minus e power x upon x to the power 5 into 1 by sin y. Or sin y into dy upon dx equals 7 upon x cos y.
Hi.
Okay. Now put cos y is equal to t. Sin y into dy upon dx is equal to minus dt upon dx. Now we can solve the equation. Okay, now proceed. Okay, guys, this session is over. Next session will start exactly at 9:15. Okay. In the next session, I will discuss homogeneous differential equation. Chinmay, Vishnu, Nasrin, Madhusudan. This session is over. Second session, I'll start exactly at 9:15.